Let me start with a somewhat trivial example just to contrast the notion of fast memory obliviousness to fast memory awareness. Consider the problem of sequential reduction. Let's start by reviewing the fast memory aware version. It scans the list in units of size L to match the memory transfer size. Notice that L is an explicit variable or parameter of the algorithm. But at least the algorithm is I/O optimal. It performs just N over L transfers. By contrast, suppose that the hardware in the operating system managed fast memory for you. For instance, maybe you already know about caches from the OMSCS HPCA course. If so, you could regard this hardware-managed fast memory as a cache. Or maybe you know about virtual memory and translation look-aside buffers from the OMSCS operating systems class. If so, you could imagine the operating system and the hardware acting in concert to move pages of data from disk to main memory. They would swap pages out of main memory, which would be the fast memory in this case, back and forth to disk whenever main memory is full. In either case, the purpose of the automatic systems is to let you write the conventional algorithm. It's a lot simpler. Because fast memory is automatically managed, the algorithm doesn't need to move data around explicitly. The automatic system takes each read or write, checks if the data is already in fast memory. If so, it returns the value, and otherwise it goes to slow memory in order to retrieve the value. And if it retrieves the value, of course, it'll do transfers in blocks of size L. Notice that the conventional algorithm makes no references to Z or L. Thus, we say that the algorithm is oblivious to fast memory. So, if we had a good model of how automatic data movement works, we'll be able to analyze conventional algorithms and say how many memory transfers would they incur. Given such a model, we'll be able to analyze conventional algorithms and in this case show that the conventional way to do a reduction also incurs just N over L transfers. This discussion points out two questions, which is what this lesson is all about. First, what should we assume about how the automatic system behaves? Secondly, can we create algorithms without Z or L parameters that nevertheless match the performance of algorithms that do use Z and L parameters? That's what we mean by oblivious. Though, of course, we mean it in a positive sense. One last note about terminology. We will, by convention, refer to this fast memory as cache. It's just a shortcut. Sometimes cache really means, say, virtual memory-backed main memory for disk. It helps that it's a lot easier to say cache oblivious than automatic fast memory oblivious.